This is Enceladus, a small moon of Saturn. It is the sixth largest moon of the planet Saturn. But even though it's small, that doesn't mean there's nothing unusual here. At first glance, it just looks like an ordinary chunk of ice orbiting a giant planet. Quiet, cold, and seemingly lifeless. But everything changed when Cassini-Huygens arrived there. As it orbited the Saturn system, it saw something that surprised the entire scientific community. From the south pole of Enceladus, there were massive eruptions of ice and water shooting out from its surface. It was like a giant geyser in the middle of space. And that's where countless questions began. Why is there such an eruption on an extremely cold moon? What lies beneath its thick ice? And is it possible that there's a hidden world underneath? And that's what we're going to find out. But before we continue, please like this video. It means a lot to us content creators. Thank you very much. When Cassini passed through those very icy plumes, everything became even more mysterious. Inside the ejected particles, the probe found water and organic molecules, as well as signs that there might be a large ocean beneath the ice. It's not just water, there's also evidence that there might be hydrothermal vents beneath its ocean. Just like the vents here on Earth that are inhabited by tiny organisms, even without sunlight. And that's when scientists started to consider a surprising possibility. What if there's life on Enceladus? But before this mystery could be fully answered, the Cassini mission ended. In 2017, it ran out of fuel, and to avoid crashing into moons that might possibly have life, NASA deliberately plunged the spacecraft into Saturn's atmosphere. And as a result, it slowly burned up in the giant planet. Even so, it carried the only human-made equipment that directly studied Enceladus. And until now, there are still many questions left unanswered. Is there really a global ocean beneath it? And how deep is the water there? What is really happening under the thick ice? And most importantly, could there really be life there? It's been more than a decade since we last visited Enceladus, but research on it hasn't stopped. Now, even the James Webb Space Telescope is looking at this small moon. Researchers are also continuously analyzing the old data sent by Cassini before it was lost. And what's surprising is that even though that data is 10 years old, new discoveries are still coming out until now. With so many moons in the solar system, Enceladus is one of the most unexpected places where life might exist. And what's even scarier is that we might only now be slowly starting to understand how complicated this really is. With a diameter of about 500 kilometers, Enceladus is very small compared to other moons. It's almost just the size of Arizona in comparison. It orbits Saturn at a distance of around 238,000 kilometers. There, the sunlight is very weak. It looks like just a small star from such a great distance. And because it's so far from the sun, the average temperature on its surface reaches negative 201 degrees Celsius. It's so cold that it's almost impossible for ordinary life. Because of this, it was very difficult to study Enceladus before. It's already small and its location is extremely dark. In fact, it was only in 1789 that the astronomer William Herschel first saw it. And just to catch a glimpse of this small moon, he needed the largest telescope in the world at that time. Together with his sister, Caroline Herschel, they built a massive telescope that was extremely advanced for their time. Its mirror was so large that it weighed almost half a ton, and it took them more than a year just to finish carefully polishing it. But even though their telescope was that impressive, all they saw on Enceladus was a small and seemingly ordinary ball of ice. And for almost 200 years, that's all we thought it was. A quiet and cold moon, which later turned out to be one of the most mysterious places in the entire solar system. And now let's take a look at the first image of Enceladus. Mysterious for almost 200 years as well. Since it was discovered in 1789, people have almost always seen it the same way. a cold, small, and seemingly unremarkable moon of Saturn. But everything changed in the 1980s. That's when Voyager 1 and Voyager 2 first passed through the Saturn system. Their flyby was brief, but it was enough to completely change our view of Enceladus, what they expected to find. Back then, it was a moon full of craters and looked like a dead world. But the images showed something different. There were parts of its surface that were extremely smooth, almost no craters. And for scientists, that was a big deal. Because in space, when a moon is old and inactive, it's usually covered with craters from billions of years of asteroid impacts. But Enceladus seems to have areas that look freshly cleaned. That means something is happening beneath its surface. There could be seismic activity. It's possible that the inside of the moon is still active, and it might not be a completely dead world, but that's not even the most surprising part. Scientists also noticed that Enceladus is exactly at the thickest part of Saturn's ring. A vast ring of ice and particles surrounds the planet, and as they studied it more, a strange idea formed. What if Enceladus itself is feeding that ring? What if there's material coming directly from the moon and spreading around Saturn? And that's when some started to think that maybe Enceladus is alive in its own way. Not that it literally meant aliens, of course, but a moon that is active, moving, and has energy beneath its icy surface. Because of those mysteries, Enceladus became one of the most important targets for NASA's next big mission. And that's where the Cassini-Huygens mission was born. In 1997, Cassini was launched using the massive Titan 4B rocket, and after a long and complicated journey through the solar system, including swinging by Venus to gain extra speed, it finally reached Saturn in late 2000. The spacecraft spent more than 6 years before getting there, and all of it was worth it. Because since Cassini arrived in the Saturn system, more than 4,000 scientific papers have been produced from its data. But among all its discoveries, nothing shook the scientific world more than what they saw in early 2005. During Cassini's first flybys of Enceladus, its cameras noticed something that scientists could hardly believe. There were giant geysers erupting from the moon's south pole. In the vacuum of space itself, water and ice were shooting out from Enceladus. And it wasn't just a small puff. Every second, those vents were spewing out about 250 kilograms of water and ice. And it was moving at speeds of over 1,000 kilometers per hour. That's when everything became clear. Enceladus wasn't just a simple chunk of ice. It had an atmosphere. It had active geology. And there's something happening beneath its surface that we still don't fully understand. Signs of possible life. After that discovery, NASA immediately changed the plan for the Cassini mission. They gave the spacecraft a very dangerous command: bring it extremely close to Enceladus, just about 50 kilometers from the surface. The goal was to fly directly through the plumes and sample the material from the ejected ice. That was a huge risk. Just one small mistake and the spacecraft could be destroyed after almost a decade of traveling through space. But for NASA, the risk was worth it because they were looking for something. Signs of extraterrestrial life. And honestly, to this day, that's still one of humanity's most fascinating questions. Is life truly that rare in the universe? It's amazing to think that we've reached the point where we have technology capable of searching for possible life on other worlds. And this kind of technology wasn't developed overnight. It took many years of math, engineering, coding, and scientific research to create spacecraft like Cassini. Every movement it made, every calculation, and every photo it sent back to Earth depended on extremely complex programming. But let's go back to Enceladus. It's one of the biggest reasons why we all keep going. One of the biggest reasons we keep exploring space is the hope that maybe we're not alone, according to NASA. A thing can be considered alive if it is a self-sustaining chemical system capable of Darwinian evolution. That simply means a system that can survive, adapt, and evolve over time. But how exactly do we look for that on Enceladus? For scientists, there are 4 major requirements that need to be found: liquid water, energy source, the right chemicals, and enough time for life to form. And out of those 4, the very first thing they look for is water. Not because they're sure there's no water there. In fact, it's very clear that Enceladus has water. The real question now is this: how much water is underneath it? And where exactly is it coming from? And now let's take a look at the hidden ocean of Enceladus. As Cassini-Huygens studied Enceladus more, it became even clearer that the moon in front of them was no ordinary moon. In 2006, Cassini sent back images and infrared scans from the south pole of the moon. And there, scientists saw something surprising. There was intense heat coming from beneath its icy surface in a place that should have been extremely cold. There was a part of the moon that was warmer than expected, and that's also where they first clearly saw what they call the tiger stripe. Long fissures in the ice of Enceladus. They look like large wounds that are open on the surface of the moon. But those fissures are not just simple cracks. For scientists, this is a big sign that something active is happening beneath the surface. It's like something is breathing beneath the ice. And it's from those very fissures that the powerful plumes of water and ice seen by Cassini emerge. That's where a massive crack began to form. There's a liquid ocean beneath Enceladus. And it's not just water. There could also be hydrothermal activity beneath it, which drives the giant eruptions of ice into space. For many years, scientists thought that ocean was small, like an isolated pocket of water beneath the South Pole. But as they continued to study the moon, things became even stranger. For 7 years, they carefully modeled the movement of Enceladus's surface, and they noticed something they didn't expect. The moon was wobbling slightly as it orbited. In science, this is called libration. But the problem was, Enceladus's wobble was too big to be explained by just a small ocean. And that's when the surprising realization came. The outer surface of the moon isn't directly connected to its core. In other words, it's like there's a huge layer of water in between the rocky core and the thick ice on top. And now, scientists are more confident that Enceladus has a global ocean. This means that water might be surrounding almost the entire rocky core of the moon. It's not just a small lake, but a vast ocean hidden beneath the ice. And as they study it further, the evidence continues to grow. In 2025, a new breakthrough emerged from the researchers' studies. From the University of Oxford, Southwest Research Institute, and Planetary Science Institute. They revisited the old Cassini data from the North Pole of Enceladus. They compared it with the new models of Enceladus's surface temperature in 2005 and during its summer season in 2015, and they discovered something surprising. It turns out that it's not just the South Pole that's leaking heat. The North Pole is also warmer than expected, according to their analysis. The temperature there is almost 7 degrees warmer than it should be. And for scientists, that result is very important, because this means that Enceladus is actually producing more internal heat than they previously thought. And it's also possible that its ocean beneath the ice has existed for a long time. But there's one big problem. Enceladus is very far from the sun. In fact, its average surface temperature reaches negative 201 degrees Celsius. With that kind of cold, all the water should have frozen. So the next question scientists have is this: where is the heat coming from? Hydrothermal vents under the ocean? This is where the mystery of Enceladus became even more interesting. If radioactive decay in its core is the only source of heat, like what happens on Earth, the energy it produces should be far too little. According to scientists' calculations, radioactive decay can only explain about 1% of the heat detected by Cassini. This means there is another source of energy. In 2017, a team of researchers led by Gail Schoble provided a possible answer. Because Enceladus is tidally locked to Saturn, only one side of it always faces the planet as it orbits. And because of Saturn's intense gravity, the moon is gradually stretched and squeezed as it orbits. And that pressure creates friction inside Enceladus. And that friction generates heat. But it's not enough to just have heat in the core. It also needs to reach the ocean above. And this is where their theory becomes even more surprising. It's possible that water flows down to the rocky core of the moon. It passes through the silicate minerals below. It heats up, and then it rises back up as concentrated hydrothermal plumes, like underwater geysers beneath the ocean floor. And what's even crazier is this. It could be similar to the hydrothermal vents here on Earth. In 2022, a new study led by Wanying Khan provided even more evidence. Using Cassini data, they created models of Enceladus's surface to estimate how salty its ocean is. And the result is, its salinity is just slightly lower than the oceans here on Earth. For scientists, that's a big clue, because water like this usually forms when there are what we call water-rock reactions. In other words, when water interacts with a rocky core. That's exactly what you'd expect if there are hydrothermal vents at the ocean floor. On Earth, many scientists believe that hydrothermal vents are one of the places where life first began billions of years ago. That's why the possibility that there are also such vents on a small moon orbiting a gas giant planet is one of the most exciting discoveries in modern space science. Because aside from water and heat, this also gives us another important requirement for life, and that is chemicals. Despite this, as the Cassini-Huygens continues to pass through the plumes of Enceladus, it's not just collecting photos. It also carries a very important instrument, a mass spectrometer, a device that can identify what kinds of molecules are in a sample by analyzing the mass of its ions. In other words, it's like the spacecraft's chemical detective. And when Cassini started analyzing the particles being ejected from Enceladus, things became even more surprising. It detected hydrogen. And for many scientists, that's very important, because hydrogen is believed to be one of the possible fuel sources for the earliest forms of life here on Earth. But that's not all. Cassini also detected complex hydrocarbons and other molecules that contain oxygen, carbon, and nitrogen. This means that it's not just simple water beneath Enceladus. There's chemistry happening there. And as Cassini kept sending more and more data back to Earth, scientists themselves struggled to keep up with the sheer amount of information. There were so many samples, so many chemical signals, and so many possible discoveries. But before they could finish studying all of that, the Cassini mission came to an end. On September 15, 2017, the spacecraft was finally sent down into Saturn's atmosphere. There, it completely burned up and vaporized. But that wasn't an accident. NASA deliberately sent Cassini to self-destruct because they didn't want even the slightest possibility that microbes from Earth could contaminate moons, like Enceladus and Titan. In case there is life there, they didn't want it to be contaminated by bacteria from Earth. So even though Cassini's life ended, humanity's mission did not end, because after the spacecraft was gone, that's when scientists dug even deeper into its data. In 2018, there was an analysis that confirmed the presence of ring-shaped organic molecules and simple oxygen-containing compounds. This means that there is really active chemistry happening beneath the ocean of Enceladus. But things became even more exciting in 2022. Because that's when another very important element for life was found, phosphorus. And with that discovery, all 6 main elements believed to be necessary for life were finally accounted for. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Scientists know this set by the acronym SHE and OPS. And when that list was completed, some felt like the puzzle was finally complete. But the story wasn't over yet. Because as scientists examined the old Cassini data more closely, new secrets continued to emerge. When researchers first saw the mass spectrometer readings from Cassini, they weren't completely sure about their interpretation. And there was a reason for that, because in laboratories, here on Earth, a sample is carefully analyzed in a controlled environment. But Cassini literally slammed its detector into the particles while traveling through space at almost 64,000 kilometers per hour. That's why the data results were very different. It's like the difference between a watermelon that's carefully sliced with a knife compared to a watermelon that's put through a blender. It's still the same watermelon, but the pieces will look different, and it's the same with molecules. When molecules are broken apart by intense energy, the chemical fingerprint detected by the instrument changes. That's why scientists needed to further improve the way they analyze the data. And this is where a team led by Nozer Khawaja from the Institute of Space Systems Stuttgart came in. They studied the data from Cassini's plume flybys for over a decade. And last year they released one of the most important findings about Enceladus. They used samples collected when Cassini passed just about 20 kilometers from the surface of the moon. And those samples were unique because the particles were still fresh. It had only been a few minutes since these came out from the ocean of Enceladus. They hadn't been affected by radiation from the sun yet, unlike other particles that have been floating in the ring for a long time. In other words, this is one of the purest samples we've obtained from beneath the ocean of Enceladus. And what they found here was even more surprising than expected. They found carbon dioxide, carbon-rich alkanes and alkenes, cyclic esters, ethers, ethyl compounds, and other molecules containing nitrogen and oxygen. This means that very complex chemistry is happening beneath this moon, and it could be even more fascinating. It's possible that there are hydrothermal vents under its ocean. For scientists, those molecules are very important, because they're like the Lego blocks of chemistry. The more types of molecules there are, the more possible chemical reactions can happen. And when those reactions become complex enough, they can start to show a very important characteristic: evolution. The same process that led to the existence of life here on Earth. And when you have water, energy, chemicals, and evolution, there's only one question left. Has Enceladus had enough time for life to develop? Because even though Cassini spent 13 years in the Saturn system, that's still very short compared to the billions of years needed for life to form. That's why now there's a new instrument helping in the search for the answer: the James Webb Space Telescope. Even though the Cassini-Huygens mission has long been over, the story of Enceladus is not yet finished, because now there's a more powerful instrument observing it: the James Webb Space Telescope. And when this telescope studied Saturn's small moon again, it saw something that scientists could hardly believe. A research team led by Geronimo Villanueva used almost 10 hours of observation time on the James Webb to look at Enceladus. And what they saw was even more intense than expected. There was a massive plume that erupted again from the moon's south pole, but this wasn't just an ordinary eruption. The jets of vapor and ice reached almost 20 times the size of Enceladus. It was even wider than what Cassini had previously seen. And because of that, our understanding of how active this moon is has expanded even more. But that's not the only thing the James Webb Observatory answered. For many years, there has been a big mystery about Saturn. Where does the water in its atmosphere come from? And now it looks like Enceladus may be the answer. New images have shown that as the moon continues to spew water and ice, it gradually fills the area around Saturn with a huge amount of ice particles. It's like it's creating a giant ring of ice around the planet. And because of that, Enceladus has become especially significant when it comes to life. This is the only known moon that directly affects the atmospheric chemistry of its host planet. In other words, this small moon is actually changing Saturn's environment. But those ice particles have another strange effect. As they orbit in the Saturn system, they lose electrons and become ionized particles. And when that happens, they become electrically charged. Plasma. Recently, scientists discovered that this plasma actually interacts with Saturn's magnetic field. And because of that, extremely long plasma waves are formed, reaching almost 504,000 kilometers. That's more than 2,000 times larger than the radius of Enceladus. They call these elfin wings. They're like giant invisible electrical structures that extend from the moon to Saturn. There's a main plasma stream that is directly connected to the planet, while others bounce back, creating something like a giant lattice or web of plasma around the Saturn system. And up to now, scientists still don't fully understand exactly how these work. It's amazing to think that a small moon, once thought to be just a simple chunk of ice, can affect the entire environment of a giant planet. How long will this activity last? But there's one very important question. How long will the geothermal activity of Enceladus last? Because if it disappears quickly, there might not be enough time for life to develop. Over the past year, scientists have re-examined old infrared data from Cassini. They compared it to new models of Enceladus's surface temperature. The research team of Georgina Miles and Carly Howitt discovered a very important detail: the heat coming from the surface of the moon. It almost exactly matches the predicted heat generation from its core. And for scientists, that's huge news, because this means that the ocean era of Enceladus could last for a long time. This isn't just temporary heat. It's possible that the interior of the moon has been active for millions or even billions of years, and that's exactly what life needs: time. As for future missions to Enceladus, one of the most impressive things in the whole story of Enceladus is this: even though scientists are using old data, they are still able to make new discoveries. And it's not just professional researchers who are helping with this. In 2017, an amateur astronomer named Ted Strick looked again at the old Voyager images of Enceladus, and he saw a possible water plume in the old images. If that had only been noticed earlier, the design of the Cassini mission might have been different. Maybe more instruments would have been added to directly study the plume. Maybe it would have been sent even closer to the moon. But now there's a chance to correct that. Because there are new missions being planned to continue Cassini's work, the European Space Agency is currently planning a mission that's scheduled to launch in 2042. It's expected to reach the Saturn system in 2053, and there could possibly be a landing on Enceladus by 2058. And it's chilling to think about that, because now we know that almost all the ingredients for life are on Enceladus. So the next question is this: what might we find beneath its ice? But we don't have to wait that long to get some answers about the icy moons, because the Jupiter Icy Moons Explorer, or JUICE mission, is currently traveling to Jupiter. It's expected to arrive there in 2031 to study Callisto Europa and Ganymede. Its main goal is to find out how habitable worlds form around gas giants. There are other proposed missions for Saturn's moons. One of them is the Dragonfly mission to Titan, and for the first time in the history of natural satellite exploration, they will use a drone aircraft to explore the moon. There is a proposed private mission, also called Breakthrough Enceladus, even though that project seems quiet for now. But one of the craziest concepts is the Enceladus Explorer project of the German Aerospace Center. They plan to send a nuclear-powered ice mole? Yes, literally a machine that melts ice as it slowly burrows into the moon's crust. It's like a robotic mole that will dig down beneath the ice to directly search for signs of life. And if even just one of these future missions finds even a simple proto-life process outside the traditional habitable zone, it will change the way we see life in the universe. Because it might turn out that life isn't actually rare. It's possible that there are many places in the galaxy that can support it. There's a line from Jeremy England that scientists often remember. According to Jeremy England, when there's a random cluster of atoms and it's given enough energy over a long period of time, It's not that surprising if life eventually emerges, and maybe that's exactly what's happening on Enceladus. It's possible that scientists didn't see the plumes in the old Voyager images because they didn't know what they were supposed to look for. But now we know. And because of that, there are almost certainly many more discoveries waiting. Maybe even now, there are still secrets hidden in the old Cassini data that we haven't discovered yet. And as time goes by, one thing becomes even clearer. The small moon that was once thought to be just a simple icy rock may actually be one of the most important places in the search for life beyond Earth.